This video is a test review for the Unit 10 test. So first we're going to talk about special right triangles. So in this case, we are dealing with 45, 45, 90 triangles. Even when the triangle doesn't have angle measures, if both legs are congruent, that means both angles have to be 45 degrees. So when we label, our legs are going to be L and our hypotenuse is L root 2. Notice that we have a number on the L root 2 side. So in order to get L, we are going to divide by root 2. So we have 8 root 2 divided by root 2. The roots cancel out. We're left with 8. So our legs are 8 and 8. In number 2, again, we have a 45, 45, 90 triangle. So we have L, L, L root 2. So this time we know the value on the L side, which means our other leg is going to be that same value of 13 root 3. So in order to get the hypotenuse, this time we are multiplying. So we have 13 root 3 times root 2. The numbers under the root together will multiply together, so we get 13 root 6. In 40, when we label our sides, or in 3, when we label our sides, we have L, L, L root 2. 40 is on the L root 2 side, so we are going to divide by root 2. 40 divided by root 2, we rationalize by multiplying root 2 over root 2. So we get 40 root 2 over 2, which divides to 20 root 2. So each leg is 20 root 2. The other type of special right triangle we have then is a 30, 60, 90. So in a 30, 60, 90, across from 30 is S, across from 60 is S root 3, and across from 90 is 2S. In this case, we know our S value, so to get the other two sides, we are just multiplying. So we're going to multiply 11 root 2 times root 3, which gets us 11 root 6, and 11 root 2 times 2, which gets us 22 root 2. In number 5, when we label our sides, the missing angle is 60 degrees, so we have S, S root 3, 2S. This time our value is on the S root 3 side, so we need S. So in order to get S, we are going to divide by root 3. 45 divided by root 3, when we rationalize, we get 45 root 3 over 3, which becomes 15 root 3. So S is 15 root 3. Then to get our 2S side, we are going to double that by multiplying by 2. So 15 root 3 times root 2 gets us 30 root 3. In number 6, when we label our sides, our missing angle is 30, so we have S, S root 3, 2S. We know the value on the 2S side, so in order to get S, we're going to divide. So 8 root 3 divided by 2 gets us 4 root 3. Then to get our S root 3 side, we are going to multiply by root 3. So 4 root 3 times root 3, the roots cancel out, so we have 4 times 3, which leaves us with 12. In number 7, now we're moving into our trig ratios. So fill in the table and reduce all ratios. So we have sine, cosine, tangent for angle A and angle C. So if we are using angle A, we are going to label our opposite, hypotenuse, adjacent. Remember that sine uses opposite over hypotenuse. So the opposite side is 8, the hypotenuse is 10. We can reduce that then to 4/5. For cosine, it is the adjacent over the hypotenuse. So we have 6 over 10, and that reduces to 3/5. And then for tangent, we have opposite over adjacent. So that is going to be 8 over 6, which reduces to 4/3. For angle C, we have sine, cosine, tangent. So from C, our opposite side is 6, our adjacent side is 8, and our hypotenuse is 10. So remember that our sine and cosine switch because we switched the reference angle. So our sine is now going to be 6 over 10, which is 3/5. Our cosine is now going to be 8 over 10, which is 4/5, and our tangent is going to be 6 over 8, which is 3/4. Make sure it's very important that you pay attention to what is your reference angle. In number 10, in triangle ABC, tan of B is 11 over 60. Find the sine of B. So first we're going to draw our triangle with angle B. If we know tangent, tangent is the opposite over the adjacent. So if we have our triangle opposite hypotenuse adjacent, the opposite side is 11, the adjacent side is 60. In order to do the sine of B, we need to know that missing third side. So to find the missing third side, we're going to do Pythagorean theorem. Because it's the hypotenuse, the variable is by itself. So x squared equals 3,720, or equals 11 squared plus 60 squared. So that equals 3,721. So we take our square root, x is 61. Now that we know x is 61, we want the sine of angle B. Well, the sine of angle B is opposite over hypotenuse. So the opposite is 11. The hypotenuse is 61. In number 9, solve for x if the cosine of 2x plus 9 equals the sine of 5x minus 17. So together, the angles sum, which is addition, equals 90. So we have 2x plus 9 plus 5x minus 17 is equal to 90. That gets us 7x minus 8 equals 90. 7x equals 98. So when we divide, x is 14. So building off of that, in triangle RED, what is the relationship between angle R and angle D? Is that they equal 90 degrees, which means that they are complementary. Okay, and why is that true? Well, if we do the sine of R, that's opposite, so we're going to say ED over the hypotenuse RD. If we do cosine of D, that's the adjacent side ED over the hypotenuse RD. So why are they equal? Because they use the same side in their ratios. Okay. So now we're going to solve using our trig ratios. So remember that we're going to round sides to the nearest tenth and angles to the nearest whole number. So every problem starts the same. Based on the angle or a variable as an angle, we are going to label our sides. So based on this 20-degree angle, we label opposite, hypotenuse, adjacent. Remember, I always do the opposite and the hypotenuse first. The leftover side is the adjacent. If I look at this problem then, I know the adjacent side and I know the hypotenuse. That is going to be cosine. So we have the cosine of 20 equals x over 14. When the variable is on top, we multiply. So we have 14 times the cosine of 20 equals x. Now we're going to go over to our calculator and we're going to type 14 cosine of 20. Remember, we're rounding to our nearest tenth, so that is going to be 13.2. In number 12, x is the angle, but we're still going to base our sides off of x, so we have opposite, hypotenuse, adjacent. This time we know the opposite and the adjacent have information, so this is tangent. So the tangent of x equals 8 over 12. When we want to find our angle, we are going to use the inverse. So the tan inverse of 8 over 12. So we're going to hit second tan, which is going to put that little -1 there, equals 8 divided by 12. Angles round to the nearest whole number. So the 0.6 is going to round us up to 34 degrees. In 13, based on the angle that's 27, we have opposite, hypotenuse, adjacent. Opposite and hypotenuse have information on their sides. So we are using sine. So the sine of 27 equals 8.2 over x. When x is on the bottom, we divide. So x equals 8.2 divided by the sine of 27. It's a side, so we round to the nearest tenth. This is going to be 18.1. In number 14, a ladder is leaning against the side of the building. Okay, so if this is our building over here, this is our ladder. The ladder is 30 feet long, and it makes a 40-degree angle with the ground. How high does the ladder reach on the side of the building? So how tall is that? So that is x on the vertical side. When we label our information, then we have opposite, adjacent, hypotenuse. So we have information on the opposite and the hypotenuse. So we're going to use sine. The sine of 40 equals x over 30. Because x is on top, we are multiplying. So we have 30 times the sine of 40. So we get 19.3. So that would be 19.3 feet. In number 15, two surveyors are measuring the slope of the land. One surveyor is standing on top of the hill that's 12 feet tall. The surveyors are 100 feet apart. So this is where we got to be careful. If I have one surveyor here and one surveyor here, that's going to be the diagonal distance this time. What is the slope of the hill? So how would it change from the one to the other? So if we label our sides, opposite, adjacent, hypotenuse, again, we're using sine. So the sine of x equals 12 over 100. So we have the sine inverse of 12 over 100. Second sine inverse of 12 divided by 100 is going to be 7 degrees, which makes sense. It's a hill, so it's not going to have a steep incline, just going to go up a little bit.